Now, let us remember what the support was. Let's say we have an association rule. If you buy honey, you will buy milk with it. Then support was the percentage of cases in which honey and milk were bought together in a market basket, were contained in a market basket. So this tells us that raising the minimum support level that we specify while running a priori keeps the association rule set at a manageable level. So if we raise the support, only a few market baskets will get above it and will be included in our study. So that seems to be tempting. But at the same time, it might have the effect of deleting some really interesting rules. So we're actually sometimes are looking for that needle in a haystack. So there is no easy way out of just retaining a couple of rules and going with them. Therefore, the need to deal with a large set of association rules is unavoidable. Setting the support and confidence levels for association rules is completely arbitrary, so it might also depend on a specific data set. So you specify a level of confidence and support, you get a really few levels, rules, then you just change it for that specific data set. Now, association rules are useful for generating a hypothesis for further studying and also for finding unexpected connections. So it's really such a device. In computer science, there's a plethora of methods for association rules visualization. So there are many of those that we didn't consider. We considered like the main ones only, and thus the sentence continues that only the most far-reaching of those cut across the IT business domain border. So there are really very many scientists who are working their careers on association rule development. And only the most important ones are those that are used by business people in tools like SAP Predictive Analysis. Now, there is a very famous and fake example which says that people who buy more beer buy more diapers. So this essentially tries to model the behavior of people, and then they say that if a family head goes to a store and in the evening he's going to be buying some diapers, he's going to grab some beer to go with it. Now the question is, what do we make of this information? How do we react? Do we put the expensive beer next to diapers, for instance? And how do we understand human behavior from it? So there might be a couple of reasons why this bear together with diapers would happen. Theoretically, it could be, I don't know, the family head going to a store, or it could be some people just don't know how to end their parties and will buy diapers just in case to put forth a nasty joke. So, anyways, the point is that there is always a question of how to interpret those rules. This like really subtle information that comes forward. How do we act as a business to take some to take some positive outcome out of it for us? It's possible to generate a large number of trivial associations. So, for instance, there are some papers in educational domain which are using association rules and which are stating things like students who took a course took its prerequisites. Well, of course they did. They had to. Or if you do poorly on the exam, you fail the course. Well, naturally, because the exams are what are used to calculate the course score. Now, this brings us back to the IT business domain border. So it's good to be on this side of the IT business domain border, because association rules without much domain knowledge can lead to pretty trivial findings. So it's good that we can still use the most important methods of association rules here. Now, furthermore, there's negative association rules and more complex rules that are really, really interesting. So, for instance, negative association rules tell us what doesn't go together. So, how to really model that? So, a rule might say people who don't buy people who buy diapers don't buy car bags. even though 30-year-old males buy both. So there you have the negation. People who buy diapers don't buy car wax. How do you model that into your data, that the car wax isn't bought there? And the more complex rule, even though 30-year-old males buy both. Another complex rule with negation would be people who take advanced data mining don't take hierarchical linear models in educational domain, even though everyone who takes either has advanced math. So here you see that it's really been built by a couple of simpler rules. So there might be a rule which says that people who take advanced math can end up taking advanced data mining, and this has like lower confidence because some people will end up taking data mining as their specialization, other will end up taking those hierarchical linear models. So this is the second simple rule it's composed of. People who take advanced math might end up taking hierarchical linear models, but it tells us that those two like domains can be diverging from each other, and there is no like perhaps not enough cross-border exchange of information or knowledge of the other domain. So once again we have negation, we have more complex rules, and built from simpler rules, and more complex information coming to us as we try to describe the reality. Let's look a little bit more on association rules, and we're going to create a drawing here the way we did in the first predictive analysis association rules software video. So file new, text file is the input with CSV. The file is groceries, which we used locally, not from the University of Arkansas dataset. So I'm going to create it. And now we'll have to go to predict, take the algorithm, which is R a priori, put it here and configure it, which is the confidence level is going to be 0.5. Support is going to be 0.001. Data is going to be in transactions format, with item column being the product and transaction ID column being the ID. And we'll create the rules and we'll run it. And it's going to run for a while, so let's pause for a while in the meanwhile. Okay, so it's done. And now we're going to go to visualize. There we check cursors translated, analysis 1 is what our analysis is called, and we will select the a priori. Now we have on dimensions, we have confidence, lift, and support as numeric values and rules. We'll take the numeric values, click on their settings, and click on create measure. And we'll do that for all three of them. This way we can handle them on a graph, but right now it sums the confidence levels up. So what we need to do is click on those settings and do change aggregation to none. So we will have a separate value for every rule. And now what we did previously was we chose from scatter plots the bubble chart, and we took and put support on x-axis and confidence on y-axis, whereas lift was the bubble width and rules were legend color. So this is the graph we already looked at. You can see the cutoff at 50% and 0.01%. You can see the rules that are above it. And this graph we already looked at. So for instance, we can go to a single rule here. Other vegetables go with sour cream together to be bought together with milk. Support level is 1%, which is quite high. Confidence not that high, 51%. So we do see there's some kind of a relationship that most of the rules either have support, like more support relatively, or they have more confidence. But on the other hand, there's still other rules, like for instance this one, which have both support and confidence to a certain extent. And citrus fruit, root vegetables, tropical fruit to go together with other vegetables. There is some support, there is some confidence in the rule. But now let's do a different thing. Namely, I'm going to go back to scatter graphs. So we make all the bubbles, so to say, with equal width. And now I'm going to take away confidence from y-axis and replace it with lift. So what we get is a graph which has a depiction of support and lift. And now here we see a much more either-or relationship. There really are few rules, only very small percentage of rules which have somewhat of both in relative terms, some support and some lift. Whereas there tends to be such a thing that if you do have like high support, if you're present in very many market baskets, you don't have relatively that much lift. So that's the one kind of rule. And then again, there is a rule where you have relatively more lift, but not that much support. So that could tell us that, or I would like to stress here that for instance, for this rule, tropical fruit yogurt to go with whole milk, though it's not that the lift is that low. The lift here with this high support rule is 2.02 itself, but it's in relative terms. If you have relatively much support for your data set, you're not achieving the lift, and if you have relatively high lift, you're not achieving the support.